So we can transport energy by either moving objects or by sending waves within an object. Now, in some ways, waves and objects, or waves and particles, can behave very similarly, and in some ways they're very different. So let's look at some of the similarities and differences between waves and particles. Okay, so they can both carry energy. And in fact, they can both also carry momentum. You can send momentum with a wave, or you can send momentum with particles. However, in particles you're sending the actual matter, and in waves you're not, so the medium stays where it is. So particles can go in straight lines. Can waves go in straight lines? Well, waves in a string certainly go in a line because they just travel along the line. If I have a water wave coming into a beach, it can be very straight. Those wavefronts can be very straight as they come in. So they can go straight and they can go in lines. But if I put ripples in water, then they do tend to spread out. Is there some way of making a wave in, say, water that goes in a nice narrow straight line? And the answer is actually yes. If you have very high frequency waves, then you can make them go very much like little pulses of particles. There will still be blurring and spreading out at the very edges, but the scale of that spreading out is typically on the order of the wavelength, and the wavelength can be very small for certain kinds of waves. And when we go outside that regime, we see a very stark difference between particles and waves. So particles exist in a particular place, and they also have a particular velocity, whereas waves are spread out. A water wave can be anywhere on the entire surface of the water, and indeed all over the surface of the water. And it can be going not just in one direction, but a different direction, and different parts of the wave can be going at different speeds. As an extension of that, if you have one wave, one oscillation of the medium, one small displacement, coming in contact with another traveling wave, when they come in contact with each other, the two displacements just add up. And so if you have a displacement up, then they add up constructively and you have a bigger wave. But if they're displacing in opposite directions, then they cancel out and you get no displacement at that point. And that's called superposition. So if they add up like that, so in other words, they're coming in and maybe this one might be going one way and the other one might be going the other way. When they're just like that, then you can see that this point's going up and this point's going up at the same time. And that means they're going to add up to be a bigger thing. And so those two things have what's called constructive interference, where they add together. On the other hand, if you have one like this, then the other one is going the other way at that moment in time, then when you add those two together, then you're going to get nothing, no displacement. And that's called destructive interference. So let's look at two simple waves interfering. You can see that as they're moving, they're spread out, but when they pass through each other, there's constructive and destructive interference, and then when they've passed through, they're just themselves again. Because the waves are going up and down at different points, when they pass through each other, they don't have complete destructive interference or complete constructive interference. It happens differently at different points in space. And in fact, if you look at the energy or the momentum carried in that wave, it doesn't change while they're passing through each other. And so it has a certain amount of energy beforehand, a certain amount of energy all the way through, and then that is conserved at the end as well. One thing that particles can do that waves can't do is travel at different speeds. The only reason a wave travels at all is because of the interactions between different parts of the medium. So the speed of a wave is a property of the medium. So for example, supposing I was trying to communicate by throwing rubber balls with messages written on them, I could throw those at any speed I liked. But if I was trying to communicate by sound, then I'm limited by the speed of sound. If I shout louder, all I'm doing is changing the amplitude of the sound wave. I'm not actually changing how fast it travels. And the fact that the speed of a wave in a medium is basically only dependent on the medium actually provides a limit to how fast you can make a boat. Because boats tend to make a wave as they move, and then they tend to sit in that wave as they travel. So if the boat drives harder, it doesn't make the wave go faster, it just makes it have a higher amplitude. And so that really limits how fast it can go, and that's called the hull speed of a boat.